Hey everybody, Mrs. Bixler, and we are really kicking off now chapter 6, which is all about linear equations. It's one of my fave chapters. I love it so much, and I'm excited to jump in with you. So everybody knows, I think, Rosie's, which is like a self-serve frozen yogurt place in Old Greenwich. If you haven't been there, I bet you've been to one super similar where you fill up your little cup with yogurt and then you put as many toppings as you want and you pay by the ounce. Okay, so picture walking in, filling in your cup, and bringing it to the register. They weigh it, and you pay by the ounce. All right, so you've got that in your brain. All right, so here we go. So let's say that it was 10 cents an ounce. So how much would you pay for 5 ounces? Obviously 50 cents, right? So how did you get that? Well, you said 10 cents per ounce times 5 ounces gives me 50 cents. Cool. All right, let's do it for 3 ounces too. So 3 ounces, we know I'm still paying 10 cents for every ounce. So times 3 ounces, and that's going to be 30 cents. Cool. And then what about for 10 ounces? All right, so 10 cents per ounce times 10 ounces is going to be 100 cents or a dollar, right? Cool. So let's look at what we just set up here. So I've got a bunch of things that didn't change, right? I've got these tens in here that did not change. So if I'm thinking about like a constant value in my equation or like in this relationship, I know no matter what, I'm always going to involve the number 10, right? But something here varies. And if you look, all of these numbers vary, right? So they vary, and what they are representing is the number of ounces. So let's call that X. So right now I have 10 times X representing how much money I'm paying per ounce. And then wait a second, something else is also varying. It is this. It is my amount that I paid, right? So the total amount that I paid, this dollar amount, is also varying. And so I'm going to give that a different variable. I'm going to give that the variable y. And if we think about it, when we think about what we were talking about earlier, when we talked about comparing x's and y's, when we talk about two variables, often we talk about x and y. And so that's why we just sort of like have gotten into the habit of that in algebra. So look what we've got here. We've got a nice little equation. I know that the amount of money that I am spending here is dependent. It depends on the number of ounces that I put into my cup. So if I put 1 ounce into my cup, or 10 ounces into my cup, or 40 ounces into my cup, if I was really hungry, right? I know that that is going to impact the amount of money that I spend. And it's not going to be the other way around. So the amount of money that I spend depends on the number of ounces in my cup. So that's an important concept here. We're saying that y depends on x. So that because y depends on x, y is going to be our dependent variable. Y typically in math is going to be your dependent variable, and it will be for our work in chapter 6. So our dependent variable is y, and that makes x our independent variable. So that's a really important relationship between independent and dependent variables. So we're really used to seeing x on the horizontal axis, remember, and y on the vertical axis. And so that kind of relationship we'll watch kind of build and grow. But variable, an independent variable is going to be x typically. And x is one that operates on its own. So a great example of an independent variable would be time, because time keeps marching on no matter what happens. And a dependent variable is always going to be your y. It's going to be something that is impacted by x. So, if you talked about like the number of hours that you're studying and how that impacts the grade that you get on your final exam. So, as the number of hours you study goes up, that's your x variable, then your grade hopefully would also go up, and that is your y variable. So, like the dependent variable, the number of hours, I'm sorry, the grade on your final exam, that's your dependent variable. And your independent variable is the number of hours that you study. So let's look more deeply at this dependence in terms of Rosie's. So we just made a couple points here. So let's say I think we had like a 3, right? So if we put 3 ounces into our cup, what did we say we paid? We paid 30 cents. So I'm going to go up to 30 right here. And if I got 5 ounces in my cup, I paid 50 cents. Cool. And then let's say, like, just for the sake of it, let's say I put 1 ounce into my cup. All right, I know I paid 10 ounces. If I put 2, I paid 20 cents. I said 10 ounces before, you know I meant 10 cents. So now look what happens here. We've got a nice little line. And this line represents the relationship between X and Y, because here is the number of ounces that I put into my cup. That is my X variable, and my Y variable is the amount of money that I spent. And so if you look here, there is a positive relationship between these. As the number of ounces goes up, the amount of money that I spent goes up as well. So there are sort of other relationships, right? Other more independent and dependent relationships that we've talked about before. So in this case, we've got the number of ounces of frozen yogurt and the amount of money that I spent. We talked about, the number of hours, right? The number of hours I study and the impact that that has on my final exam grade, right? What would be some other ones? I want you to pause the video and just come up with some in your brain. And we're going to see some more later. All right, we're back. So let's look at some other ones. All right, here she is, my love, Beyonce. So I think there are several Beyonce songs that are my fave. Halo is like a nice slow jam. I think Countdown is another one that I love. Anyway, so let's say that I really like Beyonce. And so the number of times that I hear Beyonce, if I hear Beyonce one time early in the morning, then I'm pretty happy. If I hear Beyonce again later on in the day, I'm getting happier. And then I hear her again, I'm getting happier. And then again, I'm getting happier. And then I keep hearing her, hearing her. And as I hear her more and more, my happiness level goes up. Now, notice though that my happiness level did not start way down here, because that would mean that I have zero happiness when I've heard Beyonce 0 times. And that's not actually true. I'm a pretty happy person normally, even if I don't hear Beyonce. Sorry, Beyonce. So right here is where my graph would start, right? I'm pretty a happy person. If I hear Beyonce, I just get happier. Okay, cool. All right, let's look at the next one. Ooh, this is a good one. The bane of my existence. So the number of Cadbury eggs that I eat. So here is my X variable, the number of Cadbury eggs that I eat versus my dependent variable, my overall health. So my health is really dependent on the number of Cadbury eggs that I eat. So I'm a pretty healthy person, but let's say we're talking the number of bags that I eat. So let's say I start off right here. I've eaten 0 bags of Cadbury eggs. I'm good. And then as I eat more, well, I have 1 bag, I have 2 bags, I have 3 bags. So at 1 bag, my health goes down a little bit, maybe a little bit more, maybe a little bit more. Maybe at like 4 bags, it really drops, right? So there might not be a perfect linear relationship, but we can see sort of the general trend is that it's going down. We're going to talk about nonlinear relationships in chapter 6, but sort of you can tell that like just general relationship is really important. So we just talked about 2 kinds of relationships, a positive relationship and a negative relationship. So I've still got X and I've still got Y here. A positive relationship would be as X goes up, Y goes up. And a negative relationship would be like my Cadbury eggs, right? So as X goes up, Y goes down. And that would be a negative relationship. All right. So now I want you to think about what would happen with a constant relationship. So pause the video quickly and just think about it. All right, we're back. So a constant relationship, we've still got X and we've still got Y. And remember, X is an independent variable. So X is still moving and grooving, whether it's time or whatever, right? So X is still happening. But if the relationship is constant, it means it's neither going up nor down. So what's happening here is Let's say I study for 1 hour and I get a certain grade on a final exam. If I study for 2 hours, I'm getting the same grade. 3 hours, the same grade. 4 hours, the same grade. So a constant relationship would be one that does not change. So as X increases, Y just stays the same. All right. So, last little question here, and I want you to think about what happened to your stock. All right, so let's look at this. So here's my time. So my X variable right here is time, moving on. And my Y would be like the price of my stock. So look what happens here. At time zero, before we even start, my stock's like, it's worth money. It's not worth zero. And then it goes up, up, up. We've got a nice little positive relationship here. It hits October, my stock starts to plummet. And then it goes up a little bit in March. And then look what happens. We get a little constant, steady relationship there. So my stock value is not going up or down. And so you'll see a lot of these in real life. And again, we're going to talk mostly about linear relationships, and we'll move on to some nonlinear later. But this sort of relationship, understanding that as X increases, Y can either go up, down, stay the same. That's really important. So go ahead, tackle the homework. You're going to crush it, and I'll see you soon. Thanks.